Today, I'm going to be talking about how we actually use SurrealDB in production to scale personalization at a very large company. All what I can say about the company name, they're in the middle of the transaction. It rhymes with socks. So if you can guess the name, that's on you, not on me. My name is Zeyad, but I go by Z. But before we jump into SurrealDB and how we use it, let's first talk about LLMs. I think you cannot have a conference without someone talking about LLMs, so I apologize if you hate LLMs in advance. So LLMs, typically, you need like few things to have a fully functional LLM. Like for you to go on ChatGPT and actually ask it for things, there are a few things that happen under the hood to make an LLM work in production. First, you need the LLM, the actual model, the actual AI model. So pick your poison, right? Like some people are like Anthropic fans. Some people are like, no, I like open source Llama. Some people like OpenAI. They only have one C-level executive now. I don't know if you want to use them. Also memory, you need a memory. Like LLMs are, they don't remember what you say. You need to store memory in a way where you can actually retrieve back what you said and pass it to the LLM. So every time you kind of have to refresh. It is stateless in that sense. You need prompts. Everybody heard about prompt engineering. So you actually, what you type in the query. And you need the vector store, and this is where SurrealDB comes in pretty good. Essentially, you take in all the data you have, whether that's plain text documents, PDFs, products, images, audio, whatever your flavor is, and actually store it somewhere so you can retrieve it for later part in the LLM or the actual conversation. So I'm going to give some examples. Thank you, Sandro, for priming everybody about embeddings and stuff. So this is going to get a little technical. There's a lot of rust here, so I'll try to be brief. Essentially, for an LLM, you can set up Llama. If you are like want to use open source, Llama3 is pretty good. It's pretty easy to set up. There's an actual Rust crate that has the Llama sort of definition. You can pass it actual messages like show me the product any Nancy Sinatra fans that want to get some white boots. Pass it and see what it's going to tell you. It's actually not going to give you any boots, but with some work you can get it to give you some boots. Memory, memory is like there's fancy sort of, you can add memory into Redis, add like 5 different databases. I think Postgres offers memory. There are online solutions where you can go pay for memory. This is a very simple memory. Obviously, you can do it in Redis or whatnot. SurrealDB actually has that sort of capability baked in. So here, an example of memory, just to give you guys a flavor. Memory is just essentially is a long string of text. That's all what it is. So right here, you have a vector of some messages, which is like what the user asked and what the LLM responded with. And the memory is just a long string, which is the concatenation of everything. And obviously, prompt templates, handlebars. If you use Jinja, shame on you. Use handlebars. It's much better. So you can define a prompt template. Essentially, this is what defines like system messages and what the user actually can input to the. So you can make text a bit more variable. So you can pass it data to actual text. And for an LLM to work, you need to give it what the system is. Like you are a creative designer. What the user is asking for and what the assistant actually responded with. So here you can actually invoke the template and just add stuff to the template as the template grows. So you just initialize it once and you add stuff to the template, and you can render the template. It just looks like plain text. Vector store, again, you can embed your data using whatever embedding models. There are a plethora of embedding models on Hugging Face. I don't have a preference. Just pick one and go with it. That's typically how I go. But essentially, just takes text or images and actually use that embedding model to store it somewhere. So that's all what the vector store does. It just saves that embeddings, like Sandra mentioned in the previous presentation. If you've used LLMs before, you'd be like, well, what about chain of thought? Like we hate prompting. Only now there's one paper out of Stanford that actually is saying no to prompting. There's a new way to do, it's called DSPY. It's a new way to sort of talk to LLMs without prompting them. I'm a bit old-fashioned, and this project has been going on for a while. So prompting, it is the standard now. But you can do with SurrealDB prompting or chain of thought with prompting. So you can combine chain of thought and prompting all in one shot. And I'm going to talk a bit about that. So what is the problem with like LLMs in general and like all that stuff, right? You have a user query, like what I showed before, user typing, hey, I want some boots like Nancy Sinatra, right? Like it's such an obscure sort of request from a user. And how do you relate that to products you have in your database? And obviously you can spin up so many databases and figure out like how to connect them all together. But for a very simple query, the contextual, which is Nancy Sinatra, and the biggest thing, which is the chain of thought component, is the context facts. So you need to give the LLM some facts about the actual person that is querying this text. So that question, right? So the context is like, oh, this person was searching for wedding. So you don't want to show boots that are too edgy or night out. That this person returns boots in some cases, right? So you want them to show something they have not returned before. So how do you build this like context facts? And this context facts, I just put 2 here, but it could be very long, right? So like if you have a rich history on a specific customer, you can add as many context facts as on the actual prompt. That being said, most companies, I don't know where you guys work, but there are a lot of desperate systems. Data about specific things are stored in all kinds of different places, and it's very hard to actually get all the context about a user very easily, right? And you want the assistant to respond with, look at these, right? Like that's essentially what you want at a basic LLM level. But the key core of what SurrealDB actually play a powerful role is the context facts. And you can do essentially not chain of thought, you can do pipelines. So you can actually take questions from user, grab some context, add it to the template, and sort of do chains in a very good way without necessarily compromising on performance, right? So this is where SurrealDB comes in and super powerful. I'm going to show you some stuff from what's actually running in production here in a second, but I want to talk about SurrealDB superpowers. Obviously, it's built in Rust. This application specifically has been running for a month without having any incidents, which is surprising. All my code breaks. For some reason, this one did not. So kudos if you use Rust, kudos for you. I actually rewrote this one a couple of times. I said flavorful, and then I changed it to flavorless, right? But SurrealDB is flavorless in a good way, right? Like you can write SQL, you can have no SQL, you can just store some documents, and you can do graphs, right? So it doesn't force you sort of like what flavor of specific application you want to use. Like you want to use Gremlin and you want to deal with Neo4j. It doesn't really force you to follow a specific pattern. It is flavorless in that way, and you can store pretty much anything in it. And simplicity is very easy to define, like schemaless objects, right? If you're a big, I was talking to some Postgres power user here, you have to define a schema ahead of time. And SurrealDB, there's actually sometimes, a lot of times you don't know what the schema is until you actually have the data. There is a schemaless option, so you can actually have a schemaless record and pipe, and it's ever changing without necessarily having to define types and all that stuff. It's a schemaless in that sense. This is actually some sample models of running. Like, for example, I showed you the context. We have a model which is the lifetime value, how much you've spent online in the last 52 weeks, what's your lifetime value. You can store all of that and relate it to the customer and get that is a high value user. You spends a lot of money on shoes or whatnot, so you can get back the lifetime value. And essentially, the testing for SurrealDB, you can actually test using just memory. You don't need like a backend whatsoever. So SurrealDB has this capability where you can just like instantiate a client that's in memory. It's kind of gone after you run some tests. You can say it has a very, very powerful feature like namespaces and databases. So you can make it multi-tenant in that way. So if you have multiple models and you want to isolate them in a good way, there's the idea of namespaces and databases. And essentially you define a type, which is called LTV, and just like pipe it in the database, and you have whatever is in the database is you can actually verify that it's in your model. Also, another example from what is running in production. Technically, the relate, I think Sandro talked about the relate function. You can relate with complex structures in e-commerce specifically. You have products and you have variants. Variants are sizes and colors, and you want to relate so many things like this person liked this color, but in a different size, or this brand in a different size. So having that relationship in a database and expressed well is actually super powerful, because you can build not just like a simple, if you've ever built a database, you have a one to many, many to many, but like what else you can do, anything else beyond many to many. This in this approach, you can build variants of any types and kind of relate them back to the master product. And then for any user to actually feed the context, which I talked about, you can do this parallel query, which is like you can grab the options, which is like if you want to buy perfume, it's typically on weight, not on size. So you can actually build option groups and variants and query all of that in a single shot and pipe it back to the LLM without even having to sort of think twice where the data is coming from, because it's all pre-related and all predefined in your schema. So for example, if you want to find a full context about a person history, depending on what LLM you use, like Anthropic takes a very large context. Some other LLMs don't take as big of a context, but if you can pipe it in, essentially, if you can query it from SurrealDB and pipe it in, the LLM is going to get smarter about what your historical records are. And I think Sandro also talked about this, which is SurrealDB offers embedding in the database, so you can actually embed all your text on insert. So if you have an Llama or an open API, you just call the embeddings endpoint, and it would store all those embeddings in the database as well. So this is all good and dandy, right? But like when you're working for a large company, you know, it's like, what about scale? Like, how well does this thing scale? SurrealDB offers two different ways to scale, right? Which is the TIKV and Foundation DB, the two distributed backends. Like if you have, millions of records, millions of recommendations, RocksDB might not be the best case. You want it to scale. There are different backends. It's just a compute engine, and whatever you store your data, that's on you. Obviously, SurrealKV is coming, and I can't wait for it. But essentially, TIKV and Foundation DB offer distributed, so you can run it on multi-node. You can run as many nodes as you want. It scales pretty. You can run 100 nodes of TIKV or Foundation DB. That's totally up to you. So we actually use the Foundation DB. But before I jump into that, doing a TIKV is not super difficult. You can just spin up a TIKV cluster of whatever memory. You can spin up 100 of those if you have the money and you want to make Jeff Bezos rich or even richer. And you just connect to, from SurrealDB, you can connect to the TIKV endpoint that you spun up. And it would just work. And SurrealDB becomes, you get the full functionality, the graph, everything. It's just a different compute engine, or a different storage engine, which is TIKV. For Foundation DB, very, very similar, very, very similar setup. This is what we actually use. You have 3 logs, 3 storage. You need a coordinator. You need like a cluster controller. I'm not going to talk about all of this, but essentially what you need to do, you need to build SurrealDB with Foundation DB support and just pipe in Foundation DB, the cluster file to your SurrealDB, and it's just going to work. If you want to manage your own database, this is what it looks like. It's tough, right? Like you look at this graph and be like, well, I have to manage coordinators. I have to do storage nodes. If you ever had to deal with Elasticsearch storage nodes and compute nodes, like good luck scaling that thing. Is never fun for anybody. The whole thing is like databases are hard. Picking the right one is hard. SurrealDB, I think it makes it very easy, very palatable. You can ideate and get a product working in record time. We pipe a lot of data in SurrealDB. Like, 50 million records a day at least. We use Kafka to actually pipe in from all the different data sources across the company to create records in SurrealDB. And you can time travel, like I think Sandra mentioned. So you can look at the previous state of the record. You can fire events, all that stuff. It's very scalable. Again, we use it to pipe Kafka. If you've used Kafka, you can send billions of messages a day. SurrealDB can support that, and it's been thoroughly tested from like just a load testing perspective. Embeddings, you can store as many embeddings as you want. It's just a field. So we actually have, this is a sample of the embeddings. We have Clip, we have Jinja, we have BERT. It's pick your embedding models. You can store all of them if you want. Some of them are good for other use cases. So just make sure that you can pipe in more data so you can use it later. Don't worry about the scaling because it scales pretty well. And don't use LangChain. If you use LangChain, good for you. But essentially, you can create, like, embed the documents. You can add routes because SurrealDB graph capabilities. Essentially, you can say, in this scenario, call those 5 models. In this scenario, call this other 5 models, and build contextual sort of understanding for LLM without necessarily having to build a lot of chains that sort of take a long time, and it's all Rust-based, right? Fun stats. We have about 4 million customers getting recommendations from SurrealDB on a monthly basis. This is the low estimates. We have actually a little bit more than that. We have about 1.5 million recommendations going out on a weekly basis at least. That's the minimum when there's no event or sort of advertising. And again, like I mentioned in the past, we have no incident in production since we actually launched. So it's actually pretty good. It's been working very well for us. So happy to share it with you guys.